Hello and welcome. Ever get that feeling that the world is running on some kind of secret code? Well, you're not wrong. In a lot of ways, it is. And today, we're going to crack that code by looking at two incredibly powerful mathematical tools, the beta and gamma functions. And trust me, this is not going to be a dry math lecture. We're about to find the hidden math that powers our everyday lives. Okay, let's jump right in. So, let me start with a question for you. What on earth could your favorite movie and waiting for a bus possibly have in common? It sounds totally random, right? But the answer connects them both, and it's been hiding in plain sight this whole time. The secret ingredient is the math that predicts and models these exact things. I mean, think about it for a second. How does Amazon estimate your package delivery time down to the hour? What are the real chances you'll win that online game you're playing? And how in the world does Netflix know exactly what you want to watch next? These are the kinds of mysteries we're going to solve today. Let's start with the first character in our story, the gamma function. I like to think of it as the master of the waiting game. Seriously, its entire purpose is to help us understand and predict, well, how long we have to wait for things. Now, you might remember factorials from school. Like 3 factorial is just 3 times 2 times 1, which equals 6. Pretty simple. The gamma function takes that basic idea and gives it a massive, massive upgrade. So here's the crucial difference. Factorials only work for whole numbers. You can't calculate 3.5 factorial. It just doesn't work. But with the gamma function, you absolutely can. It stretches this powerful concept to cover all the numbers, filling in all those gaps. That's its superpower. And here's what that actually looks like. Now, don't worry about the complex formula. Just look at the curve itself. You can see how it smoothly connects the dots for 1, 2, 3, and 4, but it also gives us an answer for every single point in between. It creates this continuous, flowing picture of how values grow. So why does any of this matter? Because the gamma function is the perfect tool for any how long until question. How long until you get to the front of the line at the bank? How long until a light bulb in your house burns out? How long until your package finally arrives? All of these are real-world waiting games, and the gamma function helps us model the time between these kinds of random events. Okay, let's move on to our second hero. Meet the beta function, which I like to call the hero of probability. If the gamma function is all about how long, the beta function is all about what are the chances. Here's the breakdown of what the beta function does. It looks at a situation with a bunch of possibilities, and it maps out the probability of different outcomes on a scale from 0 to 1. And you can just think of that as a 0% to 100% chance. Simple as that. And get this, the shape of its graph tells the entire story. If the peak of that curve is way over to the right, close to 1, it means success is super likely. If the peak is on the left, near 0, then failure is probably going to happen. And if it's that nice symmetrical hill right in the middle, yep, you're looking at a classic 50-50 shot. The shape is the prediction. And that's really the key thing to remember right there. Anytime you're dealing with the probability of something, a yes or a no, a win or a loss, a pass or a fail, chances are the beta function is the mathematical tool being used in the background to figure it all out. Okay, so we've met our two math heroes. Now let's see them out in the real world, actually doing their jobs. Remember our master of waiting, the gamma function? This is it. This graph here shows the probability of how long you might have to wait for a bus. You can see that most people wait a pretty short time, but that long tail of the curve shows that it's possible, even if it's less likely, to have a really long wait. This is absolutely crucial for planning things like bus schedules, staffing call centers, and managing hospital queues. And here's our hero of probability, the beta function, in action. It's used to model the chance of success versus failure. Is it going to rain tomorrow? What are a player's real chances of winning a game? Will you pass that exam? Any situation with two main outcomes can be modeled and predicted using the beta function. All right, now for the big reveal. This isn't just some old-school math from a textbook. Beta and gamma are front and center in the most advanced technology we use every single day. This is the math that powers AI. Take a look at this chart. It shows the whole family of statistical tools that data scientists use. And what do you know? Right there, you can see beta and gamma. They aren't just solo acts. They're part of a powerful team that helps machines understand the world through data. So what are their specific jobs on the team? Well, the beta function is critical for something called Bayesian probability, which is just a fancy way of saying it lets a system get smarter by updating its beliefs as it gets new information. It's how AI learns from experience. And the gamma function is used to model continuous things like time, helping AI understand rates and how long things take. And this brings us right back to our original question, that amazing moment when Netflix perfectly recommends a new show you'll love, or when YouTube can actually predict if a new video is going to be a viral hit. Well, it's our two heroes, Beta and Gamma, working together in the background. They're analyzing probabilities, they're modeling user behavior over time, and they're making the predictions that power these incredible recommendation engines. So I'll just leave you with this one final thought. Now that you know about this hidden mathematical machinery, what are you going to see it in next? Maybe the timing of the traffic lights, the weather forecast, your social media feed? The secret code is literally everywhere. And now you know how to start looking for it.